Assalamualaikum warahmatullahi wabarakatuh. My name is Aliya. So I will be presenting the answer for Lab 1 exercise, question 1 pseudocode. So the question is asking for payroll of the month. So we'll start with our input. So we label, let's say, working hour per week is A and regular rate as in B. And our output, let's say, gross pay per month is C and net pay is D. So we start our code. We will get A and B from our user. If A is more than 40 hours, C, our gross pay per month, we will times with, our A will be minus 40 to get that extra hour, and times with B, which is the regular rate, and times with 1.5 for overtime hour. And we will plus with 40 times 4 times B. So what is 40 times 4 times B? Is 40 is the hour, the total hour per week, times 4, which is we have 4 weeks in a month because it says gross pay per month, and B is the regular rate. Else, C is equals to 14 times 4 times B. This is the regular calculation without adding the extra time, which extra time rate, which is 1.5. So we'll end the if. Next is if C is more than 1,500 ringgit, then our D, which is the net pay, equals to gross pay minus 10% of our gross pay. If else, then our net pay D is equals to C, which is gross pay per month. And we will display the net pay and gross pay per month. That is the end of our pseudocode. All right, next for our flowchart, we will do the same thing. Go with start, and our input is we get A and B, and then we go to our decision, which is if A is more than 40 hours. If the decision is no, then C equals to 40 times 4 times B, which is explained in the pseudocode. If yes, then C equals to 1.5 times B times A minus 40, which is the extra hours that we need to get, plus 40 times 4 times B, which is the regular rate that we are going to calculate with. Then we use the connector page here, go to the site. If C is more than 1,500 ringgit, if yes, that means D, which is our net pay, is equals to gross pay minus 10% of our gross pay. If no, then that means D is equals to C. Net pay equals to gross pay. Both of them are done, and we will go to display C and D and end our flowchart. Okay, next for question 2 pseudocode, it is asking for a Richter scale number. So Richter scale number. So Richter scale number, we label it as N. So we start our pseudocode with start and then input N, which is the Richter scale number. So we're going to switch N, and case if N is less than 5.0, it will print little or no damage and straight away go to the end program. Then case if N is less than 5.5 and N is more or equal to 5.0, it will print moderate damage and straight away go to the end program. And then case if N is less than 6.5 and N is more or equal to 5.5, it will print serious damage and straight away go to the end program. And case if N is less than 7.5 and N is equals to or more than 6.5, it will print disaster. And if else is default, which we're going to print catastrophic damage, and we will end the program. All right, for question 2 flowchart, we're going to start with the start bubble and then go down to our decision diamond. If N is less than 5.0, if the decision is yes, then we will print little or no damage and straight away go to the connector page number 2, which lead to the end program. If no, we will go to the second decision, which is N less than 5.5 and N is equal or more than 5.0. If yes, it will print moderate damage and straight away go to page connector number 2 and again lead to end program. If no, as you can see here, we'll connect it to page connector to number 1. We go to the other side here. I'm sorry for the weird elbow line connector. I don't know what happened, but so if N is less than 6.5 and N is more or equal to 5.5, yes, it will print serious damage and straight away connected to the end program. If no, we go to the second. It goes to the other decision, which is N equals to 7.5 and N is more or equal to 6.5. If yes, it will print disaster and straight away go to the end program. And then if no, if it does not pass any of this decision, it will print catastrophic damage and end the program. So that's it from me. Thank you very much.
So now let us proceed with pseudocode for question 3, which is about the equivalent parallel resistance and equivalent series resistance, and we must list our input and output. Input is resistance value, number of resistors, and output is equivalent series resistance, Rs, equivalent parallel resistance, Rp. And we will start by setting Rp equals to 0, number of resistors also equals to 0. Then we will get the number of resistance, read the number of resistors, and then we will have our do while post-test loop. Rs Rp equals to 0, get the number of resistors, and if selection statement, if n larger than 0, our iteration equals to number of resistance, and while loop, while I larger than 0, then we will continue getting the resistance value. Rs equals to Rs plus R, and Rp equals to Rp1 R, and our iteration decrement by 1 after we calculate each resistance value for each resistor. Then if our I smaller than 0, then we will end our loop, and Rp equals to 1 over Rp, and display Rs and Rp, and end our if our n becomes smaller than 0, so that we can calculate until the last resistance. Then we will also end our end loop and end the whole pseudocode. So now we will proceed with our flow chart, which by first we will get our number of resistors, our data, input data number of resistors equals to 0, Rs, Rp equals to 0. By getting all these input data, we are getting into do while post-test loop. Then we get the number of resistors, and our if selection statement, if larger than 0, then iteration equals to number of resistors. Then we will have our while loop. If I larger than 0, then we will get our resistance value for that resistor, then Rs, Rp. Then we will have our iteration decrement by 1 after each iteration. Then if we manage to get I smaller than I equals to 0, then we will have our Rp equals to 1 over Rp. Then we will display Rs and Rp, then end our do while post-test loop and end the whole flowchart. Next, we will proceed to our question 4 pseudocode, which is about the saving account transaction, and we must use our input and output, which our input is previous account balance, and our value, it can be positive or negative value, and our output will be transaction type, whether it is withdrawal or deposit, and our new account balance. And we will start by getting our previous account balance, which is our input data. Then we will set our sentinel value equals to 0, and we will have our while loop pre-test loop, while value not equals to 0. If value larger than 0, then we print deposit, else we will go into withdrawal. If absolute value larger than previous account balance, then we will print error message, value equals to 0. Absolute here will help us to convert a negative number to a positive number and help us to determine whether the amount of withdrawal is sufficient for our previous account balance, whether our previous account balance is sufficient for our transaction, for our withdrawal. Then we will end our if, then we will have our new balance, which is equal to previous account balance plus value, and value can be also withdrawal or deposit, as withdrawal will be negative value, and we will have to display our new account balance, then end our while loop, and finally end our pseudocode. So now we will proceed to our question 4 flowchart, which we will start by getting our input data, previous account balance. Then we will proceed to our while loop, while pre-test loop, which if the value is not equals to 0 true, then we can proceed with next statement, which is value larger than 0. If not, we will straight away skip and end. Then if value larger than 0, the if selection statement, then we will have to print deposit. If false, then we will print withdrawal. And for withdrawal, if our absolute value larger than previous balance, then we'll have to print error message, value equals to 0. Our balance will not change. And if false, then we'll have a new balance also. Then for deposit, it is also the same. We will have the new value. Then we will have our new account balance, then end our loop. And thank you.